Concerns about using used overcurrent devices and electrical heavy-ups are indeed valid for several reasons. Firstly, consumer protection is a major consideration. Homeowners are paying for a new service and they deserve to have new equipment installed. This includes the overcurrent devices. New equipment ensures their safety and the overall reliability of the electrical system. Secondly, liability is a significant factor. New overcurrent devices typically come with warranties. This provides a level of protection in the event of a device failure. However, using used devices could expose both the electrician and the inspector to potential liability. If a used device fails and causes property damage or physical harm, questions will inevitably arise regarding the device's history and condition. Thirdly, the unknown history of used overcurrent devices presents a considerable risk. These devices may have been subjected to previous overloads, short circuits, or other conditions that could have compromised their integrity. It's difficult to assess the remaining lifespan and reliability of a used breaker, making it a less desirable option compared to a new one. Fourthly, while the National Electrical Code, or NEC, doesn't explicitly mandate the replacement of all overcurrent devices during a heavy-up, it does provide guidance that supports the use of new devices. For example, NEC 240.83 states that all new conductors must be protected by overcurrent devices that are properly rated for the load they serve. Additionally, NEC 110.3b requires that all overcurrent devices be listed and labeled, indicating that they have been tested and certified to meet specific safety standards. Fifthly, as an electrical inspector, you have the authority to interpret the NEC and to determine whether used overcurrent devices meet the necessary safety requirements. You can exercise your discretion to require the installation of new overcurrent devices. This decision can be based on your concerns regarding consumer protection, liability, and the uncertainty surrounding the history of used devices. It is strongly recommended that inspectors require the installation of new overcurrent devices in all electrical heavy-ups. This practice offers several important benefits. 1. It ensures that the homeowner receives a new and safe electrical system. 2. It reduces the risk of liability for both the electrician and the inspector. 3. It eliminates potential issues associated with using overcurrent devices with an unknown history. Understanding overcurrent devices, or OCDs, is paramount. An overcurrent device is designed to protect an electrical circuit from excessive current, which can cause overheating, damage to equipment, and even fires. These devices come in various forms, including circuit breakers and fuses. They work by interrupting the flow of current when it exceeds a predetermined level. Circuit breakers are electromechanical devices that can be reset after tripping, while fuses are single-use devices that must be replaced once they have blown. When selecting overcurrent devices, it's essential to consider several factors, including the ampacity of the conductors they are intended to protect, the interrupting rating of the device, and the specific application requirements. The ampacity of a conductor refers to its current carrying capacity, which is determined by its size, material, and insulation type. The overcurrent device must be rated to protect the conductor without allowing it to overheat. The interrupting rating of an overcurrent device is the maximum amount of fault current it can safely interrupt. This rating must be high enough to handle the potential fault current at the point of installation. In residential applications, circuit breakers are the most common type of overcurrent device. They are typically installed in panel boards, which serve as the central distribution point for electrical circuits within a home. Circuit breakers come in various sizes, ranging from 15 amps to 200 amps or more, depending on the size and type of circuits they protect. Fuses are less commonly used in residential applications, but they may be found in older homes or in specific applications, such as protecting motors or appliances. It's important to note that overcurrent devices are not designed to protect people from electric shock. Ground fault circuit interrupters, or GFCIs, are used for this purpose. GFCIs are designed to detect small imbalances in current, which can indicate a ground fault, and to quickly interrupt the circuit to prevent electric shock. GFCIs are typically required in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor receptacles. When performing an electrical heavy-up, it's essential to ensure that the existing electrical system is adequate to handle the increased load. This may involve upgrading the service entrance, which includes the service conductors, the meter, and the main overcurrent device. The service entrance must be sized to accommodate the total load of the home, including existing loads and any new loads that will be added. In addition to upgrading the service entrance, it may also be necessary to upgrade the panel board. The panel board must have enough available spaces to accommodate the new circuits that will be added. It's also important to ensure that the panel board is in good condition and that all of the circuit breakers are properly sized and functioning correctly. When installing new circuits, it's essential to follow all applicable electrical codes and safety standards. This includes using the correct size and type of conductors, installing the correct type of overcurrent devices, and properly grounding the circuits. Grounding is an important safety measure that helps to protect against electric shock. It provides a path for fault current to flow back to the source, which causes the overcurrent device to trip and interrupt the circuit. In addition to following electrical codes and safety standards, it's also important to use good workmanship practices. This includes making sure that all connections are tight and secure, that conductors are properly supported and protected, and that all equipment is installed according to the manufacturer's instructions. When inspecting electrical work, it's important to pay close attention to the details. This includes verifying that the correct size and type of conductors have been used, that the overcurrent devices are properly sized and functioning correctly, and that the circuits are properly grounded. It's also important to look for any signs of damage or deterioration, such as cracked or broken insulation, loose connections, or corroded terminals. If any problems are found, they should be corrected immediately. Electrical safety is everyone's responsibility. By following electrical codes and safety standards, using good workmanship practices, and paying close attention to detail, it's possible to create a safe and reliable electrical system. When dealing with used overcurrent devices, consider the potential risks of nuisance tripping, reduced interrupting capacity, and compromised reliability. A nuisance trip occurs when a breaker trips for no apparent reason, which can be disruptive and inconvenient. The cause could be degradation of the internal components. The interrupting capacity of a breaker refers to its ability to safely interrupt a fault current. Over time, the interrupting capacity can be reduced due to repeated tripping or exposure to high fault currents. The reliability of a breaker is its ability to consistently and accurately trip when an overcurrent condition occurs. Used breakers may have a higher risk of failure, which could lead to damage to equipment or even a fire. When evaluating used overcurrent devices, consider these factors. Firstly, the age of the device is a factor. The older a breaker is, the more likely it is to have degraded. Secondly, the history of the device matters. If a breaker has been subjected to repeated tripping or high fault currents, it may have been compromised. Thirdly, the physical condition is an indicator. Look for any signs of damage or deterioration, such as cracks, corrosion, or discoloration. Fourthly, the listing and labeling needs to be checked. Make sure that the breaker is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. Using new overcurrent devices offers several advantages. Firstly, you get assured reliability. New breakers are manufactured to meet current standards and specifications, so you can be confident in their performance. Secondly, you get warranty protection. New breakers typically come with a warranty, which provides coverage in the event of a failure. Thirdly, you get enhanced safety. New breakers incorporate the latest safety features, which can help to protect against electrical hazards. The decision to require new overcurrent devices in electrical heavy-ups is ultimately a matter of professional judgment. However, given the potential risks associated with using used devices, it's generally advisable to err on the side of caution and require the installation of new equipment. This will help to ensure the safety and reliability of the electrical system, and it will also reduce the risk of liability. When inspecting electrical installations, always be sure to check the overcurrent protection for proper sizing and operation. Here is a recap. Your concerns about the use of used overcurrent devices are valid. It is recommended to require new devices during heavy ups. This protects homeowners, reduces liability, and ensures code compliance. New devices offer reliability, warranty protection, and enhanced safety features. When selecting overcurrent protection, consider ampacity, interrupting rating, and application requirements. Remember, GFCIs protect people from electric shock. When performing a heavy up, ensure the electrical system is adequate for the increased load. Always follow electrical codes, safety standards, and use good workmanship practices. Evaluate used devices carefully, considering age, history, and physical condition. When in doubt, err on the side of caution and require new equipment. In electrical installations, always check overcurrent protection for proper sizing and operation. This approach ensures a safe, reliable electrical system and minimizes risks.